Hello class, this is the second part of our lecture in analytic geometry, where I will discuss to you the topic conic sections. Conic sections is defined as the locus of point that moves so that the ratio of its distances from a fixed point called the focus to its distance from a fixed line called the directrix is constant. The constant ratio is called the eccentricity of the conic. So, conic sections are derived from a cone. When we take a plane section on a cone horizontally, we can form circle. This is your circle. This is your circle. When you take a plane section at this direction on a cone, you will form an ellipse. When you take a section from the base of a cone to its lateral side, you will form parabola. And if you take a section vertically to two cones, you will have a hyperbola. So the equation of conic section are always in a second degree, where we have a general equation of ax squared plus bxy plus cy squared plus dx plus ey plus f equals to 0. So, to identify what type of conic section it is from the general equation, we will use the discriminant or a formula of b squared minus 4ac for us to know what type of conic it is. So if c is equals to a and b is equals to 0, the conic is a circle. Going back from the general equation, if the coefficient of the term with x squared and the term of y squared is equal, and we don't have a value for b where the term that has xy, it is a circle. If the discriminant is equals to 0, the conic is a parabola when we try to substitute all the coefficients on the equation. If it is less than 0, the conic is an ellipse. And if it is greater than 0, the conic is a hyperbola. Eccentricity of a conic is a measure of how much a conic deviates from being circular, making the eccentricity of the circle obviously equal to 0, and it is the ratio of focal distance to directrix distance of the conic section. So if we're going to compute the eccentricity, it's just equals to the distance from the focus to conic all over the distance from conic to directrix. If E is equals to 0, it's a circle. If E is equals to 1, it's parabola. E is less than 1, the conic is an ellipse. And if E is greater than 1, the conic is hyperbola. So we come now to the first type of conic section, which is the circle. A circle is the locus of point that moves such that its distance from a fixed point called the center is constant. The constant distance is called the radius of the circle. So in a circle, we don't have a directrix here. Okay. This is the general formula of or the general equation of a circle, where we have ax squared plus ay squared, or simply from the general equation of the conic, this is supposedly cy squared, but a is equals to c. So the coefficient of x squared and y squared are the same. Hence, the equation of the circle is this one. Or we can rewrite that as x squared plus y squared plus dx plus ey plus f equals to 0. For the standard form of the equation of a circle, because in making it in a standard form, you will be able to determine the center of a circle as well as the radius of the circle. So when we change this general equation to standard form, we should have a form of equation like this: x minus h square plus the quantity of y minus k square equals to r squared. Example: what is the radius of the circle with the following equation? So how can we change that into the standard form? First, rewrite the problem: plus y squared minus 4y. So I will transpose negative 12 on the right hand side. We will have positive 12. So just to recall the standard form, the equation: x minus h square plus y minus k square equals to r square. So we should have a sum of squares of binomials. So how can we do that? So as you can see here, we have terms of x squared and negative 6x. So we have to form an expression that is a perfect square of a binomial. That it is an equivalent of a square of a binomial. So in order for us to make that perfect square, we shall introduce a number. Okay, we will add a number here on the left hand side on the equation, and we will put a number on the right hand side of the equation, the same value that we added. So that process is called completing the square. So x squared minus 6x. So what would be the third term for it to be a perfect square? So the value for that should be, since the middle term of a perfect square expression is equals to the twice the product of the square root of the first term and the third term. So if I have 2 times the square root of x squared, which is x, and what value would I put here, or the square root of this number, so that we have a middle term of negative 6x. So for us to have a negative 6x, it should be negative 3. So the square of this number will be right here. So 3 squared, negative 3 squared is positive 9. So again, a perfect square expression has a middle term equivalent to twice the product of the square root of the first term and the third term. Or the other way, in easily determining this value that we will add here, we'll just divide the coefficient here on the middle term, which is negative 6x, divide it by 2. So negative 6 divide 2, negative 3. Then square it. Take the square of that number. Negative 3 raised to 2 is positive 9. Just like that. Plus, okay, let's group that. Then we have y squared minus 4y. So what number we will put here? So negative 4 divided by 2 is negative 2 raised to 2 equals to positive 4. Therefore, it is equals to 12. Since by completing the square, if we add a number here, we should also add that number on the right hand side of the equation. Because if we are going to simplify the equation, these numbers that we added will be cancelled, and we will go back to the original equation. So now, convert this into a square of a binomial that's equivalent to x minus 3. square plus y minus 2 square is equals to 12 plus 9 plus 4. That's 25. So, x minus 3 square plus y minus 2 square is equals to 25 is equivalent to 5 square. Now we are in the form of, or the standard form of the equation of a circle, where we can easily determine here the center. So the center is equivalent to h minus k, h and k. So if your value or your sign here on the equation is negative h, for the coordinates of the center, it shall have the opposite sign. For the grouping or the group for x minus h, okay, that's for the x axis, x value for the coordinates, and take the opposite sign of that. The same way with the k on y value, take the opposite sign. So here it is negative 3. You should put here in the coordinates for the center positive 3. Then for negative 2, this is positive 2. The radius is equals to 5 units. So let's take a look on what it looks like on the graph. Okay, so here is your equation: 6x squared minus 6x plus y squared minus 4y minus 12. So we have already determined the center somewhere along 3, 2. So here's your Cartesian plane, here's your origin. So 3 and positive 2. Right here is your center of the circle. Then we have a radius, distance to any direction from the center to the circle, which is equals to 5. So if this is your center, just count 5. Okay, 5 units from the center. 1, 2, 3, 4, 5. It's also the same to the left. 4, 5. Then you can draw down the circle. Next, another example. What is the center of a circle with the following equation? Center of a circle, change it again, this general equation to standard form. Okay, let's just group those terms with x variable and also with the y variable. Then negative 31 will be positive 31 if we move that on the right hand side of the equation. By completing the square again, let's make a grouping. Divide the middle term by 2, so we have a negative 1. Then you take the square of that. Negative 2 divided 2 is negative 1. Then negative 1 raised to 2 is positive 1. Plus quantity of y squared minus 4y, this is the middle term, divided by 2. Negative 4 divided by 2 is equals to negative 2. Then raised to 2. Negative 2 raised to 2 is positive 4. So that's your values. Positive 1 plus 1 plus 4 plus 4. So equivalent of that is x minus 1 squared plus. So if you wonder how can we come up to this negative 1, how can I easily determine this negative 1 or the sign of negative 1? So actually you can refer to the sign of the middle term, negative here. That's why this is also negative, and take the square root of the third term. Okay, y negative square root of 4, 2 square equals to 32 plus 4, 36. Rewrite again. So the standard form of equation is really helpful in determining the radius, the location of the center of the circle, or in drawing the circle in a graph. So that's your answer. Locating the center is positive 1, and for y, positive 2. And the radius is 6 units. Okay? That's your answers. But center on this required here. For the drawing, here's your drawing for this general equation. Okay? The center is 1, 2. So 1 unit from the origin going to x, and 2 units to the y. This is the location of the center, and count 6 units from the center to form the circle. Okay? Next. Come now to the conic shape parabola. It is a locus of point that moves such that it is always equidistant from a fixed point and a fixed line. That fixed point is called the focus, and that fixed line is called the directrix. So as you can see here, this is an example of parabola where the location of your focus is somewhere here with a distance of a from the vertex. Now, this is your directrix. So, any point on the parabola is equidistant from the directrix. Okay, so the distance here is also a from directrix to the vertex, and from the focus to the vertex is also equals to a. Now, let's say in this point, the distance from the directrix, let's say v, is also equal to the distance from the focus to the parabola. So that's how you draw a parabola. So this is the general equation of a parabola. As you notice, in a parabola, only one variable is on the second degree on the equation. It's either x or y. So if your axis, if the axis of the parabola is parallel to the y-axis, this is your equation where x is the second degree, and for the axis parallel to the x-axis, your term which has a variable y has a term which is in the second degree. Now, if the parabola is at the origin, here's your general equation. So if your vertex is at the origin, if it opens to the right, this is your equation. Y squared is equals to 4ax. If it is going to the left, you have an equation of y squared equals to negative 4ax. So if it opens to the right, positive 4ax. Opens to the left, negative 4ax. Next, if it opens upward, like this, opens upward, your general formula is x squared equals to 4ay. If it opens downward, this x squared equals to negative 4ay. Now, if the vertex is at any point on the Cartesian plane, where we have coordinate of the vertex of h for the x and k for the y component, the parabola with vertex at h and k coordinate, if it opens to the right, we have again a standard equation of y minus k square equals to positive 4a quantity of x minus h. So it's the standard form for parabola with vertex at h and k if it opens to the left. So y minus k squared equals to negative 4a x minus h. If it opens upward, x minus h squared equals to positive 4a y minus k. Just like that. And if it opens downward, have x minus h squared equals to negative 4a y minus k. Elements of parabola, the focus is located at distance from vertex to the direction of parabola's opening. The directrix is at distance from the vertex and it is a straight line located to the opposite side of parabola's opening. Vertex is the point extremity of parabola, the highest point for open downward, it is the lowest point for open upward, rightmost point for the leftward, and leftmost point for rightward. The coordinates of vertex is denoted as h and k. Axis is the line of symmetry of parabola. It contains both the focus and the vertex, and always perpendicular to the directrix. Latus rectum, denoted by LR, is a line perpendicular to the axis, passing through the focus and terminates on the parabola itself. The total length LR is 4a. So, if you are required to determine the length of latus rectum, it's just derive from the standard equation and determine 4a, where S stands for the distance from focus to the vertex. Your a there. Eccentricity of parabola is always equals to 1. Okay. Example. In this given equation, y squared equals to 16x. Determine the focus. Determine also the equation of its directrix. And determine the length of its latus rectum. So from that form of equation, you can easily identify that the standard form that we can use for that is y squared is equals to 4ax, or it is the standard equation for a parabola where the center is at the origin, the vertex is at the origin, and if this is positive 4a, it is opening to the right. So our parabola opens to the right. If we're going to draw that here, is your origin, it is opening to the right. So this is drawing for the parabola y squared equals to 16x. Okay, so based on the equation, we have 4a. So your 4a here is 16. So therefore, divide both sides by 4. Your a is 4 units. So to determine the coordinates of the focus is located from the vertex with the distance a going to the opening of the parabola. That's your focus. So we will just add a on the x value of the coordinates of our vertex, which is coincident with the coordinate of the origin. For the focus, okay, just add 0 to a. Have 4, and for the y, okay, it's just the same because it is at 0 coordinates. So that's your answer on question number 1. Question number 2, determine the equation of its directrix. Now the directrix is located opposite the opening of the parabola, and it has a distance from the vertex, which is a. Okay, so there's a line. If the axis of our parabola is along the x-axis, the directrix should be perpendicular to that axis. Okay, it's perpendicular. So we have already a distance a. Our x therefore is equals to, what's the value here? X is equals to, at any point of the directrix, x is equals to negative 4. That's negative 4. Now, to form the equation of the directrix, we will just get that x equals to negative 4 and transpose negative 4, x plus 4 is equals to 0. So that we can translate that into an equation of a line. So this is your answer, x plus 4 equals to 0. Number 3, determine the length of the latus rectum. Latus rectum is just equals to 4a, or in this equation 4a is 16. That's the length. Latus rectum is 16. Or if we are going to draw that here, it's a perpendicular line to the focus and ends are within the parabola. So this is your latus rectum, 16 units. Okay, 16 units in length. Next, given the equation of the parabola 3x plus 2y squared minus 4y plus 7 equals to 0, we are required to locate the vertex and also determine the equation of its directrix. Determine also the length of its latus rectum. So let's solve. So here's your problem. First, change the general equation to the standard form of the equation of parabola, since this is a parabola where term 2y squared is on the second degree, which means that if we're going to make that standard form, we put all the terms with y on the left hand side of the equation. So 2y squared minus 4y, and the other terms should be on the other side, negative 3x minus 7. Now factor out 2, we will have y squared minus 2y. This equals to negative 3x minus 7. Now by completing the squares, 2 times y squared minus 2y, shall introduce a number here. Negative 2 divided by 2 is negative 1. Then take the square of that, that's positive 1. It's equals to negative 3x minus 7. So here, since we factor out 2 on this term, the number positive 1, which is by completing the square, that number shall be added. But since it is within the grouping where we factor out 2, we shall multiply it on 2 first. So positive 1 times 2, that's the number we will put here. Okay, positive 2. Okay, so again, if we are going to simplify the equation, we will go back to this general form of the equation just to check. So 2, the quantity of y squared minus 2y plus 1 is equals to negative 3x minus 5. So just to recall the standard form equation for this type, where y is the second degree, we have y minus k squared is equals to positive or negative 4a x minus h. So x minus h x should be positive, and its coefficient should only be 1. Therefore, if we are going to factor out here -3, we will have an equation -3 quantity of x. How about this? -5 is not factorable by -3. What we're going to do is just divide -5 by -3. If we do that, the answer will be positive 5/3. Again, just to check, multiply -3 to x, -3x, -3 to positive 5/3, we will have -5. So that's correct. Now divide both sides by 2. Okay. Since in our standard form of the equation, we don't have a factor here on y minus k squared. So, cancel 2. We have y squared minus 2y plus 1 is equals to -3/2 of x plus 5/3. Now, make this square of a binomial y minus 1 square equals to -3/2 times 8x plus 5/3. This is your standard form of the equation of this parabola. Now, your vertex therefore is what? For the x coordinate, the opposite sign of this, -5/3. And for the y, we have +1. So, based on the given, we have 4a. Latus rectum. We can already determine the latus rectum by simply using this equation. We have that's just 3/2. Okay, ignore the sign. 3/2 or 1.5 units. Okay, so I've already answered number 3. Number 1, the vertex. This is your vertex. How about number 2, the equation of its directrix? So, if I'm just going to draw the parabola, it opens to the left since you have -4ax. Okay, -4ax. Opens to the left, the location of vertex, -5/3. 5/3 is about 1.67. Let's say right here 1, 2, this is 1 and 2, +1, +2 for the y axis. So let's say this is -1.67 is right here and +1. So here's the location of your vertex. Opens to the left like that. Opens to the left, which means that your directrix is located on the other side of the opening of your parabola. So what is A first? Because A is the distance that will determine the location of the directrix as well as the focus. So A is determined by 4a equals to 1.5. Divide both sides by 4. A is 0.375. So a distance of 0.375 from here to there. So again 1.67. If I use decimal value, okay, we have negative 1.67 and 1. For the location of the directrix, I will add A on the vertex for the x coordinate. Negative 1.67 plus, I'll write here so that we can easily identify, 1.67 plus A. Okay, because we don't know if your directrix is beyond this negative 1. So negative 1.67 plus 0.375, your x therefore is equals to, okay, negative 1.295. Actually, we can write 1.667 for 3 decimal places, 667, just to be accurate. Okay, let's use 3 decimal places for the coordinates of the vertex. Okay, negative 1.667, negative 1.667. So adding that, 0.375, negative 1.292. So negative 1.292 is right here. Okay. That's your directrix. Therefore, transposing that, we have x plus 1.292 equals to 0. That's your answer on number 2. That's the equation of your directrix. Okay. Next,